Hello. I'm going to gargle the contents of this entire video. Just kidding.
You weird. Measuring moles, the gram formula mass, there be a poggle on this. This is the piece that culminates in what we just learned. Use the number of moles of each atom to figure out what the mass of the whole thing is.
Right.
Okay? So we got to count them up.
Yeah, so that you can observe and obey the law of conservation of mass in chemical equations.
Yeah.
So why gram formula mass, aka formula mass?
Well, this enables us to count these atoms by massing them. We need to know things react 2 to 1, 2 to 1, 2 moles to 1 mole, right? In whole number ratios.
Let's relate that back to something a little simpler. Okay, if you're going to make raisin bread, okay, the recipe doesn't say use 373 raisins.
No.
It says use this many grams of raisins.
Or 2 cups or whatever
2 cups. You can measure by putting things on scales and putting them in other ways. You can count that way, and that's what we're going to be doing.
Yes.
Counting by massing.
Again, the coefficients cannot be grams. Do not forget that. Right? We use gram formula mass to get from moles to grams or from grams to moles. We can go back and forth, back and forth. Okay. So after we find gram formula mass, then we're going to actually use the gram formula mass part of it.
So there's a technique. It's pretty simple. We're going to write it out, and then we're going to show you a few times.
Right.
So the first thing, you got to count the number of each atom present. Counting your atoms rules.
Facts. Then we're going to multiply that by the mass of that particular atom that we know how to look up on the periodic table.
And then we're going to add those total masses up to find out what this whole compound's mass would be if you had 1 mole of it.
Yeah. Don't let him forget the molar mass game. It's a lot of fun.
It is.
It is a lot of fun. I hope you guys do it. We're going to do it. All right. You or me?
I'll do one. You do one. Got a periodic table close by?
Got one.
All right. So example number 1.
So it says we need to be able to count our atoms. So how many NAs and how many Fs? And notice he's going to take his time and write those things out. And how many of each do you see, Mr. Monaco?
I counted a 1.
I don't want it. There's 1 of each. And I'm looking up on a handy dandy reference table that the mass of Na is 23. I'm rounding that up from 22.98997. Let's be honest, that's 23. Fluorine be 19. So 1 times 23, 23. 1 times 19, 19. Add them up. Ooh, it looks like 42.
42.
And then here's the important part.
Grams per mole.
Facts. Gram formula mass. Always grams per mole. That's going to come in handy at the end of this video or next video, okay? Next one, mg and Cl. I got a 1 mg and I got a 2 Cl. Mg's got a mass of 24, looking it up. Chlorine, 35. Done that enough times, 35. 1 times 24, 24. 2 times 35, 70. Add them up, 94 grams per mole. Oh, you're doing a great job. Why don't you just stay over here? Write some.
I just want to make one point. There is 1 mole of each of these compounds, but they have completely different masses. So there is 6.02 times 10 to the 23rd particles of
in 1 mole.
There are 6.02 times 10 to the 23rd particles of MgCl2.
Facts.
But since the atomic masses of the elements are different that make them, the mass overall would be different.
It's just like mole. Correct.
Like how much 12 feathers weighs versus 12 bricks. They're made out of different stuff.
Let me do an analogy. Ready? Same number of coins. If you have 10 pennies, that has a value. And if you have 10 quarters, that has a value that's different. Same numbers of coins, different values. Here we have the same number of atoms, different masses. Okay. All right. I see 1 Na. I see 1 N, and I see 3 O's. I don't need parentheses on that polyatomic ion. NO3 is nitrate, but because we still count them up the same. And you got those numbers good all by yourself. You're doing good. Can you do 3 times 16 by yourself?
Yeah, it's because it's 45 plus 3.
Oh, nice. That's interesting how you did that. But I see what you did. I know what you did.
The adding part gets me.
Oh, there
12,
you go. So
15,
12, 15. There you go.
Carry the 1, 6, 8.
Nice. He didn't even use his fingers. I know you can't see him, but he didn't use his fingers. I'm proud of him. He did good. All right. Now, here's where things get tricky. This is the one you can't screw up because there we got to go backwards with that 2 there. If you need to, the first few times you do this, write out NO3, write it out 2 times. If you have to do that for the first time, no harm, no foul. Okay. But 1 calcium, 2 nitrogens, 6 oxygens, filling them in, Calcium is 40. Oh, he knew that. And 14 and 16. So that's 28 and 6. It's got to be 96.
90 plus 6, 96.
96. And we got to add all that up. I see 14. So that is 164 grams per 1 mole. That grams per mole is huge. It needs to be there every time. And we're actually going to manipulate that going forward. So
Yeah.
we need to have that as a thing that we're not stuck on.
Riddle me this, Mr. Milks.
All right, go ahead.
How much would 2 moles of NaF weigh if put on a scale?
Well, if 1 mole is 42 grams and you want 2 moles, let me double it. It'd be 84 grams.
There you go.
Done.
He's already doing stoichiometry.
That is stoichiometry.
That is. How much would a half of 1 mole of NaF weigh?
Well, if 1 mole is 42 grams, half of that would be 21 grams.
And now we're doing stoichiometry. If a recipe in the lab calls for a half a mole, now you can go weigh it out and follow procedures.
Right. But generally, it's going to be like the recipe calls for 1 mole, but I don't want to make that much.
Cut the recipe in half,
Cut the
like
recipe
double or
in half.
triple the cookie recipe. Cut it
Right.
in
We all
half,
want
right?
more cookies.
Guess what? No, we don't. Same
This is the
boy.
practice. I need you to get this right. We
Absolutely.
need you to get this right every time.
And since we're crushing it so hard,
We can look.
practice pages.
13.
Page 13, don't see the answers.
Yep.
And 14, don't see the answers.
Same thing. And you'll see in the box, I did it out just like this.
There's-
I listed the elements.
Yeah.
I listed how many. I listed out what their atomic mass is. I added them up. Boom. With the units.
Absolutely.
Exactly like Monaco did it at the board.
And that's the best and only way I want to see you doing it.
Yeah. And
Do
now
the
we get
18
to-
practice examples. Don't wait to try and make me do it in class for you.
I
'Cause
will.
it's
but
not that
please,
hard.
Please.
It's not that hard.
The button and turn off the video.
Hey man, I pressed the button, turn off